So today we're going to talk about doing stoichiometry with aqueous solutions. So instead of grams or moles, you're going to be given volume and molarity for your reactants or products. So let's take a look at number 6 from the assignment that we started in class. We did 1 through 5 and went over some of those in class. Let's jump to number 6 and we'll talk about that, and then you can attempt some of the others on your own. The first thing you're going to need, because it's mentioning sodium chloride and lead 2 acetate and talking about them reacting, you need a balanced equation, right? So hopefully you can tell that this is going to be double replacement. And so we end up with 2 moles of sodium chloride reacting with 1 mole of lead 2 acetate, producing 2 moles of sodium acetate and 1 mole of lead 2 chloride. So the question is asking you how many milliliters of this molarity of sodium chloride would be needed to react with 88.7 milliliters of this molarity, this other aqueous solution of lead 2 acetate. So we want to know how much of this stuff we're using, but not in grams, in milliliters. So in planning our problem, that's where we're ending. And then we're starting with our volume of our lead 2 acetate. So the question is, how do we get there? Well, I think hopefully it makes sense that in order to get milliliters of sodium chloride, the step prior to that would be liters, right? And then we learned in class previously, or with the previous set of notes, that to get to liters of an aqueous solution, like sodium chloride, because we know the molarity, we can get to liters if we know the moles, right? Because the molarity is the relationship between moles and liters. So I'm just kind of working backwards. And now to get to moles of sodium chloride, well, I could get there. Again, I'm trying to connect it to milliliters of sodium acetate. So some of you might be thinking, oh, I can go to moles from grams, right? I've done that before. But that's not really going to take me on a path that, that would bring me back to milliliters of lead 2 acetate, because that's really going to be my starting number in the problem. So instead, I'm going to get to moles of sodium chloride from moles of lead 2 acetate, because I have the ratio, which is 2 to 1 or 1 to 2 from the balanced equation. And then because it is also aqueous and I also have the molarity of it, then I can go to moles of lead 2 acetate from liters, and that's it. So that should be my whole process. Okay, so now we're going to go. Now I did this first step just sort of in my head. Milliliters to liters is dividing by 1,000, so 88.7 milliliters. And by the way, I'm starting with the volume of the lead 2 acetate because we never want to start with a molarity. We always want to start with something like grams or liters or milliliters or maybe even moles if we have it, because molarity is a ratio between moles and liters. It's not a starting point, okay? Okay, so I'm going to go ahead and just jump right to liters. 88.7 milliliters would be how many liters? 0.0887. Okay, so go ahead and think about what units would go on the top and the bottom. And if you want to pause and just see if you can make that prediction, that would be a good idea. Okay, so hopefully you said liters we're trying to cancel and moles is what we're trying to get. My plan says that, right? And then what do you think we're going to do in terms of filling that in? Okay, so it's going to come from the molarity. The 0.95 molar means 0.95 moles per 1 liter. All right, so then my next step, I'm going to go from moles of my lead 2 acetate to moles of sodium chloride. We said that was our plan using the balanced equation. And of course, those come straight from the coefficients, 2 to 1. Okay? All right, so what did we say the next step was? Moles of sodium chloride to liters, right? Okay, and so then go ahead and maybe pause and see if you can figure out what numbers are going to go top and bottom here. Okay, so I said 1.88 because that is the molarity of my sodium chloride. Notice sometimes that molarity ends up on the bottom, sometimes like over here it ends up on top. There's no rule about whether it should go on the top or the bottom of the fraction. The rule is it goes next to moles, right? So if moles is what we're getting rid of and it's on the bottom, that's where the molarity goes. And a 1 will always go next to liters, which in this case is on top. All right, and now I'm at my very last step, which is just liters to milliliters. So that should be pretty straightforward. We're just multiplying by 1,000. And so that gives me 89.64 milliliters of sodium chloride. And kind of a weird one because I only need, it looks like 2 sig figs. Molarity here only has 2 sig figs. The other two numbers in the problem have 3. So I have to go with 2, and 89.6 would round up to 90, but 90 with no decimal would only be 1 sig fig. So with proper sig figs, I got to throw a decimal on in there to make that zero, that trailing zero significant. So go ahead and set up the next problem and see how far you can get with it, and even try the last few problems on the assignment. Um, just, the further you can get, the more productive questions you can ask during class. I don't expect everybody to get those all correct, but if you'll try them, it will be a lot more productive in the next class.